Hello everyone, my name is Diksha and I am from the Bodhi Academy. So today I am going to discuss about the aldehydes, ketones and carboxylic acids chapter. In last video we have seen regarding the nomenclature of aldehydes, ketones and carboxylic acids. So in this video we will continue with the chapter and today we will be discussing about the structure of carbonyl compound and also the preparation of aldehydes and ketones. So let us see the different methods of preparing aldehydes and ketones. Okay, so we'll start with the structure of carbonyl group. So structure of carbonyl group is basically carbon having double bond and the two bonds are attached to the other groups. That is basically alkyl group or hydrogen or OH group. Okay, so this carbonyl group is having carbonyl carbon and this carbonyl group is having 3 sigma bonds and 1 pi bond. So carbon is having 3 sigma. So this is first, second and third. So 3 sigma bond and this is 1 pi bond. Okay. So this is having which hybridization? So since it is having 3 sigma and 1 pi bond, the carbon is having sp2 hybridization. Okay. So this carbon carries sp2 hybridization and now the carbon is having 4 valence electrons. So we can see that 3 valence electrons are involved in sigma bonding. So 1, 2 and 3 and the 4th electron is involved in pi bonding. So 4th electron is involved in side to side, sidewise overlap, which is the pi bond. Okay, so this is about the structure. Then we can see that oxygen is having 2 lone pairs. Okay, oxygen is having 2 lone pairs. Oxygen is having total 6 valence electrons. So 2 valence electrons are involved in the bonding with carbon and other 4 electrons are the free electrons which forms 2 electron pairs. Okay, so since oxygen is having these 2 electron pairs, there is a very high electron density on oxygen atom, and since there is a very high electron density, the electronegativity or the negative charge on the oxygen is very high. Okay, and since this negative charge is high, this positive charge automatically becomes high. So according to if you compare both the oxygen carbon, there is polarity between the oxygen and carbon, and that's why there exists a dipole moment of this compound or the carbon and hydrogen bond, and also we can see that there is a high electronegativity difference and polarity is there between carbon and oxygen. Okay, so we can say that this compound is having dipole moment, and with dipole, that is, this is negative pole, this is positive pole. Okay, and we see that this carbon being electrophilic, now carbon is having positive charge, so it will attract to the electrons. So this is the electrophilic, and oxygen being negative is a nucleophilic. That means it will attract to the nucleus. Okay, then this compound is having the structure trigonal coplanar. Okay, so the structure is trigonal coplanar and all the angles, all the 3 angles are 120 degree each. Okay, so this is having trigonal coplanar structure and all the angles are 120 degree. Now we can see that this is the neutral structure of carbonyl compound or carbonyl group, and if we try to draw the resonance structure, it will have charge. So oxygen will possess negative, carbon will possess positive charge. Okay, so this is the structure of resonance structure of carbonyl group, in which we can see this is a neutral structure and this is a structure having dipoles, that is positive and negative charge. Okay, so this is about the structure of carbonyl group. Let us go with the preparation of aldehydes and ketones. So first method is, now these are the methods which we use to prepare aldehyde as well as ketones, which we have already studied in our previous chapter. So let us discuss. First is by oxidation of alcohols. Okay, so in last chapter, if you remember, by oxidation of alcohols, if you take primary alcohol, that is RCH2OH, and if you add any oxidizing agent, suppose I take CrO3, okay, and if I oxidize it, I will get aldehyde, that is RCHO. And if I take secondary alcohol, that is RCHOH, R, and if I add oxidizing agent, then I will get particular ketone. Okay, so this is the primary alcohol which gives us aldehyde, and secondary alcohol gives us ketone. So we can take any example in place of R to produce the particular aldehyde and ketone. Okay, next is by dehydrogenation of alcohol. Now this reaction is similar to this, just the reagent differs. So if I take primary alcohol RCH2OH, dehydrogenation means what? Removal of hydrogen. Okay, so here you can take any metal, that is copper or silver, and temperature used is 573 Kelvin. So primary alcohol on hydrogenation using this copper, it will give us RCHO, that is a corresponding aldehyde. Then same thing, RCHOH in presence of copper 573 Kelvin will give us ketone. Okay, so these two reactions are similar, just the change of reagent. The reagent which we are using, that is only we can see the difference in the reagent. Okay, so this is about the oxidation of alcohols and dehydrogenation of alcohol to produce particular aldehydes and ketones. Next is by ozonolysis of alkenes. Now, if I take any alkene, that is if I take CH3, CH2, okay, and add ozone to this, that is O3, I will get a structure like this. So CH3, CH, okay. So this is a structure, that is an intermediate I will get after combining it with ozone. Then if I add zinc plus water, okay, to this particular intermediate, if I add zinc plus water, we'll get the final product as CH3CHO plus HCHO. Okay, so CH3CHO is basically formed by this, and CHO is formed from this. Okay, and later on the other atoms which remains, they will give us the side products. Okay, so our main products are both the aldehydes. Okay, now here we have taken CH3CH, that is a alkene. Propene plus ozone gives us this particular compound. Okay, so this gives us aldehyde. If I take a different compound, that is CH, okay, if I take this particular compound, that is CH3, attached, CH3, two CH3 are attached to this carbon, and then it is further attached with a double bond to this CH2. Okay, and if I add O3 to it, then what I will get? I will get CH3, C, then again here CH3, and this is oxygen, and here I will get oxygen, and then CH2, and here O. So I can see that if I take carbon having two substituents, so that is this two substituents with attached to the carbon, it will give me this particular compound. But after adding the zinc and water, what I will get? I will get ketone, that is CH3, C double bond O, CH3 plus HCHO. Now how I am getting ketone is, here I am having CH3, so this is CH3. then it is attached to C, and that C is further attached to O, okay, from both the sides. So it is giving double bond O and then this CH3. So this is how we get the ketone plus formaldehyde that we'll get from this. Okay, so this is about the ozonolysis of alkenes to give the aldehyde and ketone. Next is by hydration of alkynes. Now here we take alkyne, that is CH triple bond CH. Okay, so hydration means what? Basically we add H2O. Okay, so here we add water and also mercury, in presence of mercury and acid. Okay, so after adding this, what do we get is, here we get CH2 double bond CH and OH. So this one bond will break and we will get CH2, then two bonds will remain, that is a double bond, then this C and this H, and this OH will go and attach to the carbon over here, double bonded carbon. If I further do isomerization of this reaction, then I will get the respective aldehyde, that is CH3 CHO. That means here one bond will break and it will form CH3, and here this H will be eliminated to give the CHO. So I will get CH3CHO, which is called as the ethanol. Okay, so this is about the general methods of preparation of aldehydes and ketones using some general methods which we have already discussed in last year's chapters and also in our previous chapters. Okay, now next is preparation of aldehydes from acyl chloride. Okay, now as we have seen what are acyl chloride, we'll just see the structure. Acyl chloride is okay, this is a acyl chloride. When we react the acyl chloride or when we carry out the hydrogenation of acyl chloride in presence of catalyst palladium and barium sulfate, okay, then we will get the particular aldehyde. That is, here we can see benzene is attached to carbon double bond Cl. So benzene will be attached to a carbon double bond OH, which is called as the aldehyde. So here it is acyl chloride or acid chloride gives us the particular aldehyde. Okay, this is about the preparation of aldehyde from acyl chloride, and this reaction is also called as Rosenmund reduction. This, since reduction is carried out here, reduction means either addition of hydrogen or removal of oxygen. So here we can see there is an addition of hydrogen which takes place. So that's why it is called as Rosenmund reduction. The next reaction here is from nitriles or esters. So if we take nitrile, any compound of nitrile, and add to it the stannous chloride compound plus hydrochloric acid, we will get the particular intermediate over here which is having the double bond, and when we carry out the hydrolysis we will get the RCHO, that is the aldehydic group. Okay, so aldehydic group is obtained after carrying out the hydrolysis, and this reaction is called as also the Stephen reaction. If I take example here, I will take CH3 in place of R. So CH3 C triple bond N plus stannous chloride plus HCl will give CH3 CH NH. On further hydrolysis it will give CH3 CHO, which is the ethanol. There is one more reagent which will act efficiently to give the aldehydes, that is dival H, meaning the name is diisobutyl aluminium hydride. Okay, so when we take nitrile in presence of this particular reagent, we will get the effective product. So we will get RCN will give us RCHO, that is a particular aldehyde. So if I take example, CH3CN will give me, in presence of this particular reagent, will give me CH3CHO. Okay, so nitrile is getting converted to particular aldehyde. Then next reaction is of acid anhydride, wherein we are taking the we are taking the esters in presence of this. So esters, this particular ester, that is CH3, CH2, C double bond O CH3, in presence of this reagent, it will give me the aldehyde, that is CH3, CH2, C double bond OH. So this group will be eliminated, and in presence of this group there will be hydrogen. It will give me aldehyde, and name of this aldehyde is propana. Okay. The next reaction here we will see, that is the ethyl reaction, which is by oxidation of methyl benzene. Okay, so here we prepare the aldehydes from hydrocarbons. So let us take by oxidation of methyl benzene, which is also called as a ethyl reaction. And the first reaction here is by using chromyl chloride, that is CrO2Cl2. So when I add this toluene, now here basically we take substituted benzene or methyl benzene or substituted methyl benzene, or methyl benzene is also called as toluene. So toluene, when reacted with chromyl chloride in presence of carbon disulfide, it will give me benzene ring attached to CH, O, Cr, Cl2 twice. Okay, this particular chromium complex I will be getting, and this chromium complex on further reaction with hydronium ion, that is H3O plus, will give us the product as aldehyde. So we will get the particular aldehyde on hydrolysis of this compound. Okay, the next reaction here is using of chromic oxide, that comes under the same reaction. So here we use, instead of chromyl chloride, we use chromic oxide. So toluene, when toluene or substituted toluene when reacted with chromic oxide in presence of acid anhydride, we will get under 273 to 283 Kelvin temperature, we will get this particular group will get attached to the benzene ring, that is OC. Okay. We will get OCOCH3 group twice attached to the benzene ring, and on further reacting with H3O plus, that is a hydrolysis, and providing heat, it will give me the particular aldehyde. Okay, so here also we can convert toluene or substituted toluene into the aldehyde. Okay, next reaction is by side chain chlorination followed by hydrolysis. So here also we take the same compound, that is methyl benzene or toluene. Now here we use chlorine molecule in presence of light. Okay, so here we see that when we add the chlorine molecule, both the chlorine get attached to the carbon or attached to the benzene, and when we further do the hydrolysis here, we will get the particular aldehyde under 373 Kelvin temperature. Okay, so here toluene is giving us benzaldehyde in presence of light. And the next reaction here is by Gattermann-Koch reaction, which is a very important name reaction in terms of this chapter. So Gattermann-Koch reaction, here you just need to remember the reagent. So benzene when reacted with carbon monoxide with hydrochloric acid in presence of anhydrous aluminium chloride or cuprous chloride, so any one we can use, it will give us the particular aldehyde. So I will get benzaldehyde from benzene, and this reaction is also here, since here we are using the anhydrous AlCl3, it reminds us of the Friedel-Crafts reaction. Okay, so benzene in presence of carbon monoxide plus HCl anhydrous AlCl3 will give us benzaldehyde. Okay, so this was about the preparation of aldehydes using different reagents. Now we will see the preparation of ketones. Okay, so first preparation from acyl chlorides. Now first we have to see how to prepare the reagent which we use in producing the ketone. So first Grignard reagent, that is RMGX, magnesium alkyl magnesium halide, is treated with cadmium chloride, okay, to give dialkyl cadmium, that is R2CD. When Grignard reagent is treated with cadmium chloride, we get the reagent called as dialkyl cadmium and plus the side product of magnesium halide. So this dialkyl cadmium is used to prepare the further ketone group. Okay, so this dialkyl cadmium is then reacted with acyl chloride, and when we react this two, we get the respective ketone. So R dash C double bond O R plus 2 mgx, or here X is here we will get CdCl2 as the side product. Okay, so let us take an example here. If I take 2CH3 C double bond O Cl plus CH3 CH3 attached to CD gives me 2CH3 C double bond O plus CH3 and plus CdCl2. So this particular ketone I will get after adding the reagent, that is R2CD, dialkyl cadmium. Okay. Now next is the preparation is from nitriles. Now nitriles when combined with Grignard reagent, that is a aromatic compound, using aromatic compounds in presence of ether, we get the intermediate, and then that intermediate when treated with hydronium ion or hydrolysis, we get the particular ketone, that is CH3 CH2 C double bond O C6H5. Okay, so this whole compound is getting eliminated, and in place of this compound oxygen atom will be present, and along with this aromatic group. Okay, so this particular ketone we are getting here. And next reaction is from benzene or substituted benzene. Okay, so here we can see we are reacting benzene with acyl chloride, okay, in presence of anhydrous AlCl3. So we call this particular reaction as Friedel-Crafts reaction, okay, which we have studied in previous two chapters, that is Friedel-Crafts acylation. Okay, so what we can see in Friedel-Crafts acylation is acyl group is getting added to the particular group. So here benzene we are taking. So benzene plus acyl chloride gives, in presence of anhydrous AlCl3, will give us benzene ring attached to the C double bond O R group. Okay, so this is this particular group we will get after combining it with acyl chloride. Now here in place of R we can also take the aromatic group to obtain the product. Okay, so this is the product that we get after carrying out the Friedel-Crafts acylation reaction to obtain ketone. Okay, so these all are important reactions to prepare aldehydes and ketones from this chapter, and especially the name reactions are very important, okay, which comes for the exam. Okay, so this is about the preparation of aldehydes and ketones. Carboxylic acids we will see in the later part of this chapter, and after this part the next video will come on the physical properties and chemical properties of the aldehydes, ketones and carboxylic acid. Okay, so we will continue in the next video. Okay, thank you.